This video is going to show us how to use the rules of exponents to write expressions without any negative powers and with no powers of powers. Each base only used once in the final expression. That's what simplification boils down to. So if we take a look at a, we have 3a squared times 4a to the power of 6, parentheses means multiply. Okay, so we're multiplying everything here. So it's 3a squared multiplied by 4a to the power of 6. Well, the numbers we just multiply normally. So 3 by 4 is 12. And then the rules when we're multiplying the same variable together, okay, the same base. When we multiply the same base together, we add the powers. So it's going to be a, you only write the base out once, and then add the powers. 2 plus 6 is 8. So it's 12a to the power of 8. It's not very clear there. Let me try it again. Okay, 12a to the power of 8. Hopefully that's a little bit clearer for you now. Okay, the second one. 2x to the minus 5, y to the power of 4, all raised to the power of 3. So first of all, just check that you've got inside powers and a power on the outside of the parentheses. So there's a rule for dealing with inside powers and outside powers. Now the other thing is that you have to make sure there's no addition or subtraction in here, and there isn't. We're not adding or subtracting anything. There's only a single term. So what we do is, people like to think of it as distribution. Mathematically it's not really distribution, but it's very similar. You're going to apply this power of 3 on the outside to each of these individual pieces inside. So that's going to be 2 to the power of 3. X to the power of, x already has a power of negative 5 on it. When you have an inside power and an outside power, you multiply them. So for the x, it's going to be x to the power of minus 15. And you see how we're dealing with each piece separately? Even though this is all one single unit, 2x to the negative 4y to the 2x to the negative 5y to the 4. Even though that's one expression, we deal with each individual item inside it separately in this case. Y is to the power of 4 already, and then there's a power of 3 on the outside, so multiply. Okay, so 4 3s are 12. Okay, so when we have an inside power and an outside power, what we're doing is we're multiplying the powers. Now we're not quite finished here, because the x is a negative power, and we don't generally want negative powers. At least in this section of the book we don't want negative powers. Later on in math it may be necessary to have negative powers, but not right now. So if a piece has a negative power, we just move it to the bottom of a fraction. So we're going to create a fraction this time because we don't have one at the minute. We're going to create a fraction, and the bit with the negative power is going to be on the bottom of that fraction. So it's going to be 2 to the third, y to the power of 12, and on the bottom, x to the power of 15. Okay? Alright, hopefully that helps. Alright, this next one. 8p to the 5 over 2p squared. Again, there's no addition or subtraction. If there's addition or subtraction within either the top or the bottom of a fraction, it can lead to all sorts of complications, but we'll deal with that later on. Right now in this problem, we don't have any addition or subtraction, so cancelling is allowed. Simplification is pretty easy. So 8 over 2 is going to be 4. P to the 5 divided by p squared. What we do in this situation here is we're going to subtract the powers. Okay, so it's p to the 5, p to the 2. If we subtract the powers, we get p to the 3. And put it on the level, up or down, that had the higher power. Okay, so p to the 5 was a higher power than p to the 2nd. So we're going to put our answer, p to the 3rd, on top. Okay, so it's going to be 4p to the 3 over 1, and that is just 4p cubed. Okay, so 4p cubed over 1 is just 4p cubed. Right, part D. And we have 2 to the power of 3, m to the power of 5, m to the power of 8, all over 4, m to the power of 7n, and that is all going to be cubed. So in this case, what I would probably suggest is that we put the 3, apply the 3 to every particular item in here. So we had a 2 to the power of 3 already, and now a 3 on the outside. Remember, inside and outside powers, we multiply them. So that would be 2 to the power of 9. Okay, m to the power of 5 to the power of 3. Well, m to the power of 5 to the power of 3, that's m to the power of 15. Okay, n to the power of 8 to the power of 3, that would be n to the power of 24. Excuse me. And on the bottom, we would have 4 to the power of 3, m to the power of 7, which is now to the power of 3 as well, so that's m to the power of 21, and n to the power of 3. Okay, the 2's and the 4's are going to be a little bit of a problem here. Let's see how to deal with those. So leave that as 2 to the power of 9. Now, let's look at what else we have. We're going to have 4 to the power of 3 on the bottom, but let's deal with that in a minute. We have m to the power of 15 over m to the power of 21. So when you have an m on the top and the same base on the bottom, you subtract the powers and put your answer where the bigger power was. So the m to 21 is bigger. So our answer for the m's is going to be on the bottom. And if we subtract the powers, 21 take away 15 is 6. Okay. For the n's, n to the 24 over n to the power of 3, again, subtract the powers. This time the answer is going to go on top, so it's going to be 2n to the power of 21. Now the 4 cubed, we can, to simplify this as much as we should, the 4 cubed, 4, remember, is 2 squared. So this is 2 squared cubed. Okay? A little bit complicated. 2 squared. And we're cubing that. So we're nearly finished. The 4's and the 2's have just made this a little bit more complicated. So the top doesn't change. On the bottom we now have 2 to the power of 2 to the power of 3. Again, you have an inside power and an outside power, so multiply those powers. That's going to be 2 to the power of 6, m to the power of 6. Okay, and now the 2's, they have the same base. Okay, so if they have the same base, we subtract the powers. Put your answer where the bigger power was. 2 to the power of 9 is bigger, so the answer is going to go on top. If we subtract the powers, it's going to be cubed. So 2 cubed, n to the power of 21 over m to the power of 6. Now 2 cubed is 2 by 2 by 2, which is 8. So we can also write that as 8 n to the power of 21 over m to the power of 6. Okay, so that one took a little bit of time to work out. The 2 is the number part of it, which is what probably most of us like to deal with, or think we like to deal with. That's what causes the problem here in this one. Okay, E and F. I'm going to do F first, because it's going to require less space. Okay, and in F you have some expression all to the power of 0. So the 0 applies to everything in there, and that means we're going to have 1. Right. There's an assumption been made here that z is not equal to 0. Okay, but don't worry too much about that. Let's not worry too much about that. Let's go back and look at E. Okay, E is 3x to the power of 4, y to the power of 5, all to the power of minus 3. So we have inside powers and outside powers. So let's apply the negative 3 to everything. That'd be 3 to the negative 3, x to the negative 12, y to the negative 15. These are all negative powers. These are all negative powers. So that when we have negative powers, if we don't already have a fraction, we need to create one. And in this case, there'd be nothing left at all on top, so we use 1. When there's nothing left on the top of a fraction, there should be a 1 there. So that would be 1, and then pull all of these under, and when you move them under the fraction, the powers become positive. That's why we do create the fraction. That's what we want to do. That's how to make the powers positive. You create a fraction and move everything under. Okay, so that's your whole video on this one. Take your time as you go through them. I'm able to go through them pretty quickly because I've been doing them for a long time. You won't be able to go through them that fast at the start. Just go through the rules, apply the rules slowly. Don't apply rules where they don't fit. Okay? Better not to do something wrong than it is to break rules in this context. Okay, 10 minutes. That was a long one. Sorry.